A number of trends have converged to change how grain processors manage quality. New seed technologies and special grain production opportunities require maintaining the identity of grain from planting through delivery to end-use customers. In response to a growing demand for consistent, high-quality grains and oilseeds, Iowa State University Extension, Pioneer Hybrid International, and the Iowa Grain Quality Initiative developed this program to help growers produce and preserve the quality and identity of their grain. Using the procedures demonstrated today, along with the proper planting, harvesting, and grain handling techniques, will help ensure that you're producing the crop you planted. The entire process starts with a single question. What level of grain purity will be accepted in order to market this product? Since every producer's situation is different, you'll need to determine what level of purity you want to achieve with each crop. If your goal is 100% purity, then ensuring that your seed is not commingled at any stage of planting, harvesting, or grain handling is important. When deciding what level of grain purity is needed, consider how field isolation, cross-pollination, harvesting, handling, and storage may impact grain purity. Grain mixing from these sources is more difficult to control or predict and can be cumulative. Planting is the one step in the process you can most easily control. Following the cleanout procedures in this program will help minimize or eliminate seed mixing in the planting process. To illustrate the importance of proper cleanout procedures that help prevent unwanted seed mixing, Pioneer conducted a lab study with a single-row finger mechanism test unit and an air metering unit with a central seed hopper. Researchers wanted to see how long it would take to empty all unwanted seed after changing corn hybrids in a planter that had not been cleaned. In both cases, the planter was operated until the seed hopper appeared empty of seed type 1. Then seed type 2, which was a different color, was loaded into each planter. The last kernels of seed type 1 didn't leave the finger mechanism planter until after 9 bags of seed type 2 ran through the unit. 20 bags of seed type 2 were planted before all of seed type 1 was planted out of the air metering unit. In the finger mechanism single-row unit, 9 bags of seed equates to planting about 25 acres. While the heaviest concentration usually occurs at the start of the field, unwanted seed may persist while planting across the field. We can predict that 25 acres per unit on an 8-row planter could impact up to 200 acres. On the air metering unit, 20 bags were planted before all of seed type 1 was dropped, or the equivalent of up to 55 acres. This demonstrates how easy it is for seeds to hang up somewhere in or on the row unit or planter and later drop randomly in a row. Results may vary depending upon your circumstances and planter type. As you can see, failure to clean out your planter between changing hybrids could have a significant impact on your grain's marketability. To help preserve the identity of your grain, strive for a goal of 0% seed mixing when doing a planter cleanout. Planting just 2 unwanted corn seeds in the first 10,000 row feet results in 1/100th of 1% of unwanted seed. This would likely be unacceptable if your final product goal is 1/10 of 1% of unwanted grain. Iowa State University recently tested several planters to determine the best cleanout procedures for each planter style and seed metering mechanism. To develop these procedures, each planter was filled and cleaned 3 times. The research found that if visible seed was completely removed when changing seed, unwanted seed levels dropped below 1% within 1,000 feet of operation. The proper cleanout procedures for any planter starts with the same 5 steps. First, determine whether you'll be cleaning your planter in the field or in another location, say your farmyard or machine shed. We'll be doing our demonstration in a machine shed at one of Iowa State University's research farms. In some cases, you will see single units being cleaned. These are stock units and haven't been modified in any way. Next, find the manual for your planter and review the recommended cleanout procedures. Then make sure you have the correct safety gear. Eye protection and leather gloves should be worn when inspecting and cleaning planter parts. Rubber gloves should be worn when handling treated seed. Wear a hard hat when checking under the planter. Collect the tools you'll need, including containers for the seed you'll be removing from the planter. Finally, prepare the cleanout area and planter. If it's important to contain the seed, use a tarp under the planter. When doing a field cleanout, do it in the field you just planted. This allows you to fill the clean planter with the next seed type after moving to the next planting area. In order to inspect the underside of the planter, you'll want to make sure it's safely set up on mechanical supports. Using the hydraulic lines alone is not safe. Begin the cleanout process by inspecting the planter. Start at the top of the hopper. After cleaning the metering mechanism, inspect the underside of the planter, including the seed drop tube, double disc seed openers, depth wheels, and press wheels. Seed may have fallen during filling or may be sticking to planter parts if the soil is moist or seed openers are dirty, or if you've used graphite, talc, or seed treatments. As you can see, seed sometimes hangs up in the seed tube area. Inspect this area carefully and remove any seed before replacing the hopper. The following procedures will thoroughly clean finger mechanism planters, such as this John Deere. These mechanisms are also found on some Kinsey planters. Disengage the seed drive. Remove the seed hopper and dump seed from the right rear corner of the hopper into your seed container. Next, repeatedly rotate the seed drive. Turn the hopper upside down and shake it. Listen for any more seeds. If you hear seeds, repeat the process. In tests after 3 or 4 rotations of the seed drive, turning the hopper upside down, shaking it, and listening for seeds, just one seed was found inside one of the 3 row units upon further disassembly. Because lower belt misalignment may affect calibration, and it's unlikely seed will be found here, most operators should not need to remove the lower belt cover. If you've been simply removing the seed hopper and dumping it once, you'll find that 3 cycles of rotating the seed drive, turning the hopper upside down, shaking it, and listening for seeds adds about 2 minutes per unit to the total cleanout time. If a more thorough cleanout is preferred, you can remove the seed meter from the hopper, open the cover, remove and check the finger mechanism. Individual seeds will occasionally lodge beneath the cutoff brush. This process adds another 4 minutes of cleanout time per row. If using the soybean seed cup, start the cleanout procedures by disengaging the seed drive. Remove the hopper and dump seed from the right rear corner of the hopper. Turn the seed drive hopper 2 to 3 times, shaking it and listening for seeds. Most of the time, this should remove all seed. If a more complete cleanout is wanted, open the seed cup by removing the 2 wing nuts, turning the seed meter, inverting it, and shaking it until empty. This adds an extra minute per unit beyond simply dumping the seed. Begin cleanout procedures for a John Deere vacuum planter by removing the seed hopper and disconnecting the vacuum hose. Dump seed from the left rear corner of the hopper. Open the seed meter housing door and remove the seed plate. Carefully inspect the brush, gasket seal, and interior ledges. Remove seeds from inside the meter. This takes about a minute and a half per row. Use the following procedures to clean brush mechanism planters such as this Kinsey. These mechanisms are also found on some John Deere planters. Remove the seed hopper from the seed drive and dump the seeds. Seeds often hang up inside the brushes, so it's a good idea to take off the seed plate by removing the two wing nuts. Empty the meter and inspect brushes before replacing the seed plate. This process takes a minute and a half per row. Begin the cleanout procedures for a Case IH central seed hopper by closing the gate between the hopper and the drum. Then remove the drum and empty seed. Reopen the seed hopper gate, allowing seed to fall into a catch container. Inspect and remove leftover seed from the hopper and around the assembly components where the seed drum is mounted. Seed may be caught on ledges where different materials meet or around the seed sensor brace near the bottom of the hopper. Consider caulking or using foam insulation on areas where seed often catches. Inspect the flanges of the air intake and exhaust areas, the brush, and other components around the seed drum. Don't forget to check inside the drum, particularly around the seal. After removing all visible seed, reassemble and pressurize the air seed metering system before adding new seed. This should clear any seed left in the seed delivery tubes. Inspecting the seed hopper and seed drum area and repressurizing the system adds approximately 6 to 8 minutes for the entire planter beyond conducting a conventional seed cleanout. Case IH 1200 series individual row unit cleanout procedures start by emptying the hopper through the trap door, allowing the remaining seed to drop into a container. Inspect the hopper, making sure all visible seed is removed. Remove the vacuum hose and hopper. Next, loosen the clips and open the metering mechanism. Pull the pin and remove the seed plate. Inspect the plate and surrounding area. Remove any seed.
Kernel's stuck in that same spot again. See that?
Inspection and reassembly takes 2 to 3 minutes per unit. The following cleanout procedures will work for most models of white air planters. Remove seed from each seed hopper by removing the end cap from the seed removal tube. Inspect the seed hopper, brushing all remaining seed into the seed removal tube. Remove the seed plate by disconnecting the center attachment bolt. Inspect and remove seed in the metering area, paying special attention to the brushes. Seed falling from this area often lands on the depth gauge wheels and double disc seed openers. Turn them several times to remove all seed from this area. When tested, approximately 5 to 30 seeds per row unit were found while cleaning 3 units. An alternative to spilling seed from inside the metering mechanism into the seed opener area is to close the gate between the seed hopper and metering mechanism, and then operate the planter to remove seed from the meter. If this technique is used, make certain all seed in the hopper has been removed. Removing the seed plate and cleaning in the depth wheel seed opener area adds 2 minutes per row unit beyond simply emptying the hopper through the seed removal tube. The general cleanout procedures outlined in this section will work for most types of grain drills. If a significant amount of seed is left in the seed hopper, start by removing seed with a small scoop. Then use a shop vac to remove all seed from the hopper. Open the seed discharge gate, inspect for seed, and clean the area. Also, inspect and clean around seed drop tubes, press wheels, and the drills, tires, and frame. After carefully cleaning and inspecting the seed hopper and metering areas, inspect the planter frame, particularly near the seed drop tube, the double disc seed openers, depth wheels, and press wheels. Seed may have fallen during cleanout and may be sticking to planter components if soil is moist or seed openers are dirty. Also, inspect seed opener and planter furrow closing wheels. Producers growing identity-preserved grain are often required to keep written production records. Be sure to complete and sign those records as soon as the cleanout is completed. Experience with your own planter will help you find areas where seed may be lodged. If tolerances are low, you may wish to plant a buffer area before planting an area that will be harvested for another variety. Using the cleanout procedures demonstrated in this program, along with other proper planting, harvesting, and grain handling measures, will help assure that you're producing a truly identity-preserved crop.